So section 1.6 is called the converse of the Pythagorean theorem, and the title probably means very little to you, but it's really about trying to determine if, given three sides, if they can form a right triangle. But this section's about more than that. It's about classifying triangles in general. So if you're given three different sides and you put them together, first of all, can they make a triangle? And second, if they do make a triangle, what kind of triangle do they make? Is it a right triangle? Is it an obtuse? Or is it an acute triangle? So I'm going to make a flow chart to help you classify these triangles, or these possible triangles. So in the first bubble, we're going to say, is A plus B greater than C? Question mark. And we're talking about three sides. For example, if I give you 3 feet, 4 feet, 8 feet. And I'm going to label this one A, this one B. The biggest one has to be C. Now, A and B I could switch around, but the big one has to be C. The question is, could I put these, imagine there's like sticks, these are lengths of sticks. Could I put them together to make a triangle? Or will they not fit? So, in order to tell if it makes a triangle, A plus B has to be greater than C. So in this case, for 4 plus 3, that's not greater than 8, so this one would not make a triangle. So you have two directions to go from there. Your answer might be no, and so that means not a triangle. Sorry. Sad face. Alright, so if that's the case, you're done. There's nothing you can do. Those three sides don't make a triangle. You can't go any farther. But if the answer is yes, then, first of all, let's say congratulations. You have a triangle. Happy face. So you know you have a triangle now. At this point you have to go on farther to do another test to determine what kind of triangle it is. So I'm going to go straight down here and make another bubble. And the next question is, what kind of triangle And the test you're going to use is just the Pythagorean theorem, a squared plus b squared. You're going to compare that sum to c squared. And there's three possible outcomes. So the first bubble, and I probably way off. Oop, yep, I'm off. So the first outcome is that a squared plus b squared equals c squared. Well, if that's the case, that means it's the Pythagorean theorem. So therefore, the triangle has to be a right triangle. Now, there's another possibility. It's kind of hard to draw these triangles from this side. You could have a squared plus b squared being less than c squared. Remember, the mouth of the inequality sign always points to the bigger, or faces the bigger quantity. So if you have a squared plus b squared being smaller than c squared, it's an obtuse triangle. And one more possibility. You could have a squared plus b squared being greater than c squared. And if that's the case, it's an acute triangle. These are angle classifications, by the way, not side length classifications. So an acute triangle has all three of its angles less than 90 degrees. Obtuse triangle has one angle that's greater than 90. Of course, a right triangle has one 90-degree angle. So I want to show you, I'll do an example of how to do this test, but I just want to show you what's happening with these three cases. Let's see if I can actually draw a right triangle from the side. It's not a very good one, but anyway, there's a right triangle, and this is my C, right? Hypotenuse is directly across from the right angle. And let's say that's A and that's B. A squared plus B squared would equal C squared for this triangle. So I would be the case on the left here. Now let's say I take A and B and I make them smaller. So I'm working on this case where this sum is going to be less than the case over here. So if I shrink A and B, but not so much that it doesn't make a triangle. I want to shrink it down, but they still can connect. So maybe like this. And let's see if I can actually do this. Something like that. So they're a little shorter, but they still make a triangle. You can see that the angle goes from being a right angle to being an obtuse angle. So as A and B shrink, this angle gets bigger. It's just the opposite of what you would think. So that's why if A squared plus B squared is smaller than C squared, I get an obtuse triangle because that angle gets wider. Now in this case, if A squared plus B squared is greater than C squared, then I need to lengthen A and B. So if A and B get longer than they were in the right triangle, like that, the longer A and B get, the smaller this little angle gets. So it goes from being a right angle to a smaller angle. So that's why when this sum is greater than C squared, you get an acute triangle. So I'm going to take this off now and do a couple examples. So let me slide back on screen. So example 1. Let's go back to, let me put my original problem here. 3 feet, 4 feet, 8 feet. This is how you do these problems. You're going to label A, B, and C, just like we did. C has to be the biggest number, and don't assume that A, B, C are going to be in order, left to right. And then the first question you have is, do you even have a triangle? So let's see. Yeah, I'll just leave it like that. So do these 3 sides make a triangle? You have to do this test. Nobody squared here. It's just A plus B. Is it greater than C? Well, 3 plus 4 is not greater than 8. That's a no. So my answer would be not a triangle. Done. Don't go any farther. Example 2. Let's say I have 3 inches, 8 inches, and 6 inches. Labeling my ABCs. So A, B, this one has to be C because it's the longest. Now, let's do this test. A plus B, is it greater than C? 3 plus 6, is that greater than 8? Well, yeah, because that's 9, that's 8. So, yes. Right? That means we just did this test. The answer was yes, and so we have a triangle. Now we have to go down and answer what kind of triangle, and that's when we use the A squared plus B squared compared to c-squared test. So let's go, I'm going to go over here. And now we want to do this. A squared plus b squared compared to c squared. So 3 squared plus 6 squared. Let's compare that to 8 squared. And 3 squared, you can use your calculator. That's 45. And of course, this is 64. So my a squared plus b squared is less than c squared. And that less than makes it an obtuse triangle. So in the book gives you different directions for these problems, but I want you to do them just like this. For all the problems where they give you 3 side lengths, just figure out if it's a triangle, and if it is, what kind. That's all you have to do. So ignore the book directions for these. Let's do C. Let's do at least one more. 4, 5. So let's say 3, 4, 5. This time I'm not going to put units on them. So I've got an A, I've got a B, I've got a C. And let's check to see if it's a triangle, first of all. 3 plus 4. Is it greater than 5? Yes. Okay, so yes, it's a triangle. Now, what kind? So, once again, I've gone down to here. Yes, it's a triangle. Now we're going to answer what kind. So a squared plus, oops, I forgot the squared right there. A squared plus b squared, compare it to c squared. 3 squared plus 4 squared, and this is 5 squared. Well, this is 9 plus 16, that equals 25. This is 25. So both sides are equal to each other. So if we look on the flow chart, what kind of triangle is it? When both sides are equal, that's a right triangle, because that makes this is the Pythagorean theorem. So this is a case where it's a right triangle. And last one, example 4. Let's do let me think for a minute here. Let's see, we had an obtuse. Okay, let's go 8, 9, 7. So that's A, that's B, C has to be the 9. Well, is A plus B greater than C? Yep. Because 8 plus 7 is greater than 9. So yes, we have a triangle. And now let's see. So we answered this test. Yes, triangle. Now let's do the what kind of triangle test. B squared compared to c squared. So 8 squared plus 7 squared. How does that compare to 9 squared? 8 squared plus, and by the way, this is how I'm entering it. It depends on your calculator. I would use the calculator on your iPad that's the regular kind, not the kind where you have to write it with your finger, because it's easier to do these with the regular calculator. That's 113. That's 81. So clearly a squared plus b squared is greater than c squared. Right, so we're here at this case where I lengthened these two sides and that angle got small. So the greater than means it's an acute triangle. Acute triangle. And that's really it. It's just all you have to do is follow the chart, and it's really pretty simple.